Okay. So the first about 3 or 4 questions on the diploma will be puzzle questions. Okay? They're going to be logical thinking, sequencing, just logic type questions. Okay? So I really can't teach this. I can do examples with you, but at the end of the day, I have no idea what they're going to ask. It's just going to be logic, thinky type. It could be a Sudoku, right? It could be something like that. Okay? So let's just dive in. So it says the intention of a particular two-player game is to create a line of 4 adjacent squares. So you're going to see words that you're probably not going to be like, what the heck? So adjacent means next to or side by side. Okay. So your two-player game is to create a line of 4 squares next to each other using the same letter. It's like connect 4, right? Where you're looking to try to get 4 things in a row. To play, each player takes turns placing their first initials somewhere on a 6x6 grid. Margaret and Gerda have started playing this game as shown on the grid below. Okay, so they've each taken turns putting G's, and M's. It is Margaret's turn, and she determines that she can guarantee a win by placing the letter M where? Where should she place a letter M to guarantee herself? Now it's 4 in a row, 4 in a line. So, okay, so it's not 4 in a square. So if you're thinking it's this, then you have 4 in a square. No, it's 4 in a line. Where should she put herself so that she guarantees a win? Where? Column 2, row 4. Yep. Why is that going to guarantee a win? Because if, right, she can get a row of 4 here or a row of 4 there. So that will guarantee her win. So it says row what, column what. So row 4, column 2. So on your numeric response sheet, so on your answer key, you would fill it in like that. Okay. So I can't teach that, right? Like I can't teach puzzles. This is just you using your brain. And again, it's going to feel weird. It's like, this is on the diploma? Yes. It's called logical reasoning or deductive reasoning. Deductive reasoning is taking the information that you have and coming to some sort of logical conclusion. That's all deductive reasoning is. Okay. So here's a mathy example, a mathy puzzle. So make sure that you read the questions carefully right here. Use the information for the next 2 questions. Okay, so make sure you read all the words on the page. So 3 rows of a pattern are shown below. So row 1, row 2, row 3. What should the 5th row be? And then for part number 2, if the number 8 in the pattern is replaced by the number 9, describe a pattern that can be used to calculate the value of row 7. Okay, so row 5. So I would probably just expand it out and just keep going. So this would be 1, 2, 3, 4. This would have to be 1, 2, 3, 4, 5 times 8 times 8. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 times 8 plus 5. It's got to be D. Okay. Number 2 here. Don't mind these numbers. I just copy and pasted from a couple other old tests that I have. And again, I did not write any of these questions. These are all off of old diplomas, okay, or off of straight out of my curriculum guide. So if the number 8 in the pattern was replaced by the number 9 as shown below, okay, describe a pattern that could be used. Describe a pattern that could be used to calculate the value of row 7. Okay, so this actually is a written response question because it's a describe. Okay, so not every written response is going to be algebra and all that. Okay, so when it says describe, okay, so here's my best advice to you. when you're asked to describe something, you need to have the frame of reference of the following. You need to pretend that the people marking your test are the stupidest people in the world. And that after they read your explanation, they're like, oh, yeah, that makes total sense. Like, don't try to use fancy words. Don't try to, like, impress. They're not marking your spelling or your sentence structure. What they're marking is your explanation understandable so that I can follow along with what you're saying? If I'm not a math teacher, do I understand what you're doing? That's what it means to describe, is to be thorough enough, right? Describe like the person knows nothing. So I would just keep going here. So I'm assuming, so I would say row 3 is 1, 2, 3, right? So I would say row 7 is going to count from 1 to 7. So I would not only show it with language. Did you get done? Awesome. Thanks, Jess. I would not only show it with words, I would show it with numbers as well. And then they're all times 9. And then they're all add. And then the number here matches the row number that you want. So I'm on row 7. So what I would do, because notice see how it hasn't done the equals. It says describe a pattern that can be used to calculate the value of row 7. I don't know if you have to actually put the value of row 7 on there. I don't know. You can never have too much. 1 times 9 plus 1 is 10. 12 times 9 plus 2 is 110. 1, 2, 3 times 9 plus 3 is 111. Oh, this is kind of cool. So it goes, there's 1 1, and then there's 2 1s, then there's 3 1s. So what should ours have? We should have 7 number 1s, and then a 0 on the end. Let's see if that actually happens. So 1, 2, 3, 4, 5, 6, 7 times 9 plus 7. Yep, 7 1s and a 0. That's actually really cool. Math is awesome. Okay, so again, the description is describing it in a way so that the biggest twit in the room can still understand exactly what you're talking about. Okay, does not have to be fancy, does not have to have full sentences. And by the way, description could also mean draw a picture. It could mean draw the graph. It could be anything that you want it to be. Okay. Do you have any questions on those first couple? Okay. So I'm going to go quiet here. I'm going to pause the video, and I want you guys to try the next 3 questions on your own. Okay, you're welcome to talk to each other, but I'm going to pause the video and give you a few minutes here to try the next 3 now that I've warmed you up, and then we'll go from there. Okay, so the key with this first one is actually the very last sentence. So it says the shaded square undergoes the same movement in each subsequent step. So what that means is that if a square moves diagonally in one step, then it has to move diagonally in every subsequent step after that. So this is your original. This is where you're starting with. Okay, so it said the first square is the original. So what happened here? Well, this square moved to here. Okay, and this square moved up. That's that one there. So that means in this one is going to have to move up again, which is that one. And this one is going to have to move diagonally again, which is that one. So then what would come next This one would have to move up to here. And this one would have to move to here. So you're looking for A. So the key to that question was that last sentence. Okay. This is not a diploma that you skim. You don't skim read this ever. Okay. They will sometimes bold things, like it'll say like which of the following statements is false, and they will bold the word false. But in this one, they didn't bold that whole last sentence. They expect you to read the whole paragraph to figure it out. Okay. A student makes the following statement: vote compared to veto, as the number 8570 compares to, okay, this is just weird, but whatever. So V is still 8, E is the number O, T is the number 7, and the letter O is the number 5, so 8075. And they can be that easy. And you're going to go, that was so easy. Check one for you, move on. Okay, so again, this is a numerical response. So you're going to write 8075. Okay? Okay. I haven't tried this one, to be quite honest with you. So, okay, so a geometric pattern is presented below. In this pattern, the lower left square is unknown. Which of the following could be in the lower left square to complete the geometric pattern shown above? Okay. I was going to say my first instinct would be it has to be a square, can't be a circle. Well, that doesn't help though. Okay. Yeah. Yeah, there's pink and red. They'd probably make it more dramatic. This is also a scan, so it might not um but like on the diploma they would pick different, and also on the diploma they have to accommodate for kids who are colorblind. So they can't put two colors that are too similar together. So what they might do on the diploma is they might do like a lines and a stars and a squiggle. Like instead of using colors, they'll use design. Yes. Okay. And there's also there's two different shades of yellow, right? There's a dark yellow and a light yellow. Okay. So what's the pattern here? I see that like if I'm looking here like the white on the outside became the white on the inside, the blue on the inside became the blue on the outside. If I just focus on that. So if I do that idea here, is that pardon me? Oh, yes. That makes more sense. I was like, what have I done? I already screwed it up. So then, so my instinct then would say red on the outside. Yeah. Oh, okay. Oh, yeah. Do you see this shape right here? That's what they're doing. They're rotating it around that shape. So yeah, like the yellow and the red became the red and the yellow. So the gray and the yellow is going to become gray, yellow. Okay. And then on the inside here, blue, white became white, blue. So pink, green is going to become green, pink. Ouch. So yellow, gray, green, pink. So C. So this is one where, this is a question where, honestly, if Mr. Hughes was still teaching this course, me and him go down to the office to look at the diploma an hour after you guys started. So you guys start at 9, we're allowed to look at it at 10. This is one where me and him would sit there and go, well, we think it's this one, right? Like they kind of make you, they really hurt your head. There wasn't anything like this on the diploma, the one in January. Now, whether or not that means there's one for you, I don't know. But at the end of the day, you do the diploma. There is absolutely no math in this. Sometimes you have to throw a Hail Mary. Now, could you try to eliminate a couple choices? Yes. But maybe if you had to get down to 2 and then you do a guess, that might just be the reality on some of this. Okay? Okay. So, whoops. Set theory. So let's get into the math. So the order of the diploma is not the order that we covered the units. So we're reviewing it in the order that the diploma is going to be. So the first few questions are puzzle theory. The second set of questions are sets. Okay, so what were our key things with sets? Well, it was intersection, union, subset, Venn diagrams. Okay, those were our key things with set theory. Now, with set theory, you have to know your definitions. So whole numbers are 0 and up. Okay. Just off to the side here, you should know what primes are. So primes are 2, 3, 5, 7, 11, 13. Okay. Factors, these are numbers that divide into 12. And multiples, think of it as your times tables. So multiples of 2 is writing out the 2 times table. Okay. So even though this stuff wasn't overly hard for you, in fact, you all killed it on the exam, it's going back and remembering what all these words mean. Okay. So if I am given a definition, I usually always write what it actually is. So remember the universal will always be your biggest set. If we think in terms of a Venn diagram, the universal is the big, all-encompassing set. So whole numbers less than 15. So this would be 0, 1, 2, 3, 4, all the way up to 14, not including 15, because it says less than 15, not equal to 15. The following are subsets of the universal set. So subset means that they're inside this thing. So like A and B, I don't know if there's overlap or what, but they're inside it. So what are all the numbers that divide into 12? Well, 1, 2, 3, 4, 6, and 12. Those are all the numbers that divide into 12. Multiples of 2 greater than 4, but less than 14. So when you think of the times tables, 2, 4, 6, 8, 10, 12, 14. But we have to be greater than 4. So my first one would be 6, 8, 10, 12, but less than 14. So I would stop at 12. Okay. Now, notice they have one repeated number. So if I were to write this out as a Venn diagram, oh, they have 6 too. Yes, sorry. So if I were to write this out, 6 and 12 would go in the overlap. And then A would be 1, 2, 3, 4. And B would be the 8, 10. And then here I'd have 0, 5, 7, 9, 11, 13, 14. Now, I don't even know if I need a Venn diagram for this question, but the Venn diagram for most of you made it make way more sense. Okay. So intersection means overlap. Okay. Now, the diploma can either use the words intersection or they could write it like this. That also means intersection. So the question would just say determine A symbol B. You would know that that means intersection. Intersection means overlap. So what's the overlap? 6 and 12. Okay, take a brain break. Okay, I forgot to remind you that the question did say next two questions. Okay, so if I look at the next question here, whoops, it says, what is the value of NA apostrophe? Thank you. Okay, so what does the N stand for? Number. What does A apostrophe mean? Not very good. So the number of things that are not in A. So if I go back to that little Venn diagram, how many things are not in A? So here's A's circle. Okay, so I can't include anything in here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 things. So there are 9 numbers that are not inside circle A. Okay, so again, on your numeric response, now you always start in this square and you finish in this square. So you would put the 9 there. So it's okay to have blanks after, but you don't want to have blanks before. So you always start on the left and work your way right. Okay? Still good? Okay. So students from Jefferson were surveyed on instruments they play. 27 play trumpet, 40 play flute, 31 drums, 11 trumpet and flute, 31 flute and drums, 8 trumpet and drums, 5 play all 3, 11 play none. What is this describing? What should you be doing immediately when you start reading this? But yeah, like draw the Venn. Okay, like start off with your Venn and work your way out. Okay, how many circles do we have here? Flute, drums, trumpet. Okay, on any Venn, where do you always start? You always start with the middle. Okay, and then you're going to subtract as you go. So what number gets put in the middle? 5. So I'm going to cross that out and put the 5 there. And usually when I do these questions, I cross out the number once I've dealt with it. 8 play trumpet and drums. Okay, so trumpet and drums is this area right here. That's trumpet and drums. That area has to be 8, but I've already written down the number 5. So 8 minus 5 is 3. Remember, you subtract as you go out. 13 play flute and drums. So flute and drums. So this entire area has to be 13, but I've already written down 5, so that means that gets put in with an 8. 11 play trumpet and flute. So this whole area has to be 11. I've already got 5, so I put 6 there because 6 plus 5 is 11. Okay, 31 play drums. So what I do is I like to put 31 beside drums. So this means that this entire circle has to add to give 31. So I've got 8 plus 5 plus 3 is 16. 16 taken away from 31 is 15. 40 play flute. So this entire circle has to be 40. So I go 40 minus 8 minus 5 minus 6. 21, I think. Okay. And 27 play trumpet. So again, this entire circle has to be 27. Is it 13? Now, what's the only number I haven't used? 11 play none. So the 11 has to go there. Okay, so don't forget about that number on the outside. So it says the number of students who play flute but do not play drums. So it has to be a number. So not playing drums. So not drums. So any number in the drum circle, we are not allowed to use. So they play flute. So they have to be inside the flute circle, but cannot be in the drum circle. So it's just 21 plus 6. 21 plus 6 is 28. 28 plus 6 is 32. 32 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 plus 6 is is 27. Look at choice A. Why might you be tempted to circle A? Why might you be tempted to circle this number here? Because it's that number there, right? If the question said they only play flute, that would be A. Okay, so just because it doesn't talk about trumpet doesn't mean you can't include the trumpet number. It says you just can't include the drum number. You can include trumpet because trumpet still plays flute for some of those kids. Okay, but when you see that all, like all three or all the intersect, draw a Venn and then master it out from there. Okay, was this the next two questions? Yes. So again, next two questions. So it says here the number of students who play only trumpet. Okay, so only trumpet is just this number right here. It's only trumpet, so it would be 13. So again, when you fill that in, right? Now, these are all or nothing questions, right? There's no math, there's no multi-step, there's nothing you can go back and check your work. The only way you could screw this up is if you didn't subtract. So I'm just going to show you here what happens. So let's say you have the 5 here. Let's say you put 13 here, and let's say you put 8 there. If you go 13 plus 5 plus 8, and then you minus from 31, you may get a negative. It doesn't work on this one, but you may get a negative number out. If you get a negative number, it means you've done something wrong. But that's about the only check you could ever do with this. Okay, so this is kind of like that puzzles question again. So it says, assuming the letter arrangement, assuming the letter arrangement OREO corresponds to the number 4214, the arrangement EROO corresponds to a new number. Sorry, I should have put this in the puzzles section. This is not a set theory question. So what does EROO? So this is 4214. So EROO would be 1, 2, 4, 4. So it says that number divided by 2 would be 622. So sorry, that should have been in the puzzle section. That's not a set theory. So again, start here and then work your way across. Okay. This is, I put this in the set theory, but it might appear in the puzzle section as well. So it says the pattern below represents Pascal's triangle. You don't have to worry about what the heck Pascal's triangle is. You just have to try to find the pattern. Okay. So the fourth term in the 8th row of the triangle would be. So we need to figure out what row 7 and what row 8 would look like in order to be able to expand on this. So again, this is a puzzles question. I'm sorry, I put it in the wrong section. Okay. What's the pattern here? What do they all seem to start with? They all seem to start and finish with a 1. So that's awesome. So I'll give you a second to see if you can figure this pattern out. Okay, let's give you a little shove here. So there's one pattern that's fairly straightforward to see. Right here, see how it's going 1, 2, 3, 4, 5, 6? We could continue that down to write 7 and then 8. Okay, the exact same thing is happening over here. 1, 2, 3, 4, 5, 6. So we can write 7 and 8. Now, one thing to note is how the numbers are placed. Each row seems to place a number between two other numbers, right? Like this 10 here is placed between these two. This 3 is between those two, like it's staggered. Now, when I drew those lines in, did that help you see something? What if I drew lines in here, in here, in here? What's happening? What are they doing? They're adding. They're taking the two numbers that appear above it and adding them. Now, there are other ways that we can work patterns, but that to me is just the one I see. And then I can just then now add. And I'm just going to stop there because we want the fourth term in the 8 row. So 1, 2, 3, 4. So the answer is the 56. Now, there are other patterns. So just to show you here, this is what Pascal's triangle is so cool. See this diagonal right here? Here I added 2. Here I added 3. Here I added 4. Here I added 5. Add 6. Add 7. So you could have done that. Same thing this way. How's it run this way? 1 to 3. So add 2, add 3, add 4, add 5, add 6, add 7. And then there's another pattern here. So here you added 3, then you added 5, no, 3, 6. Well, this one's not as easy. Added 3, added 6, added 10, added 15. No, that's got to be a different pattern. It's not an add pattern. Anyway, there's patterns inside patterns inside patterns. Okay. I haven't seen a Pascal's triangle though on your diploma for quite a few years because usually Hughes always tells me when there's a Pascal's triangle question. Okay. Okay. So if you want more set theory examples, go and watch that video. Okay, so in that video, I do way more examples than what I just did here with you. Okay. Okay, what is the number of distinguishable 5-letter arrangements that are possible using? Okay, perms and coms. So permutation, order matters. These are your arrangements. The way we do almost all these questions is the blanks method. But every once in a while, we can do NPR. There's a couple special questions that you have to know about. The together questions and the identical objects. So if you go back and watch that video on perms and coms, I talk about each one of those and the formula associated with it. On the cheat sheet notes, this is something you have to have memorized. You have to memorize how to set up each of the 4 types of perm questions. Okay. So it says here, what is the number of distinguishable 5-letter arrangements that are possible using the letters in the word vertical? So think of these as Scrabble tiles. Now, when you have a Scrabble tiles question, every single time, I want you to check for identical objects Or in other words, do you have 2 Scrabble tiles or 3 Scrabble tiles or 4 Scrabble tiles with the same letter? Do you? Do you have any tiles with the same letter? No. Okay? So we don't have to worry about identical objects on this one. Okay? We're just going to do it as a straight up fill in the blank. Each arrangement must begin with a vowel. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It must begin with a vowel. How many vowels do you have in the word vertical? 1, 2, 3. So let's say we have it start with the letter A. So we take out the A tile. How many tiles do you now have left? 7. And you're going to use all of them. So it goes 7, 6, 5, 4, 3, 2, 1. The assumption here is no repeats. Once you've used the V tile, you cannot use it again. So on your calculator, you can plug this in as 3 times 7 factorial. Or you could punch it in as 3 times 7p7. You've got 7 objects, and you're arranging 7 of them. Yep. Oh, and 5 letter. Oh. Okay, so I screwed up. I need to learn to read the question. Okay, so instead of having 8 blanks, how many should you have? 5 blanks. Still has to start with a vowel. Okay. You've still got 7 letters left. So 7, 6, 5, 4. You just don't have the 3, 2, 1. So you can just punch this into your calculator exactly as it appears. Or if you want to, you could go 3 times 7 objects and you arranged 4 of them because there's 4 blanks after the number 3. And I don't know which one it is. I'm going to guess either C or D. C? Okay. So you're going to notice on this section of the diploma, so after set theory, these questions are Hail Mary questions. Like you either get one of those 4 numbers or you don't. Like you can't work backwards from the answer. You can't use process of elimination. You just have to know how to do them. And AKA you have to read the question. Every word. Okay? Okay. A school committee consists of 1 vice, 2 teachers, and 3 students. The number of different combinations. Okay. So combination questions. These ones are selections. And the order doesn't matter. All of these questions are done using the formula NCR. So N is the number that you have. R is the number that you are selecting. So let's just review one other thing. You're going to have 2 words in this unit, and or. When you see the word and, what math is that? Multiply. When you see the word or, the math is add. Okay. So this committee has to have 2 vice principals. Sorry, it's selected from 2 vice principals and 5 teachers and 9 students. So you're going to have the vice principals and the teachers and the students. So how many vice principals do you have to pick from? And you want 1. Okay. How many teachers do you have to pick from? 5, and you want 2. How many students do you have to pick from? 9, and you want 3. Now, unfortunately, there's no easy way to plug these on your calculator. They are annoying, but you have 6 hours, right? Time is not an issue for you guys. I fully expect all of you to be out of there well before the 3-hour mark. Okay. Not that you have to. Feel free to stay for the 6, but okay. You got to go hit math, then go over to PRB, and then number 3. Okay. So I'm not going to bother punching that in. I'm assuming you remember where it is. Okay. All right. Okay, so this is a sneaky question. Okay, so you have to figure out what the heck this is. So some questions are clearly arrangements. It says in the question, rearrange the tiles. Some questions are clearly combinations. How many different committee combinations can you create? They're clearly P's or C's, like clearly from the wording. This one is sneaky. So when you read it, you have to first decide, is this a permutation or is this a combination? So there are 10 teams entered in a hockey tournament in which each team plays every other team exactly once. How many games will there be in the tournament? Okay, so team A is playing team B. Okay, is that the same thing as team B playing team A? Yes. So does the order, so if I write on the schedule from 3 till 4:30, A versus B, does it matter if I write A versus B or B versus A? No. So the order doesn't matter. So if you want to write a little note to yourself, A versus B is the same as B versus A. The order doesn't matter. It's the same game. Okay. How many teams do you need to create a game? 2. Don't overthink that. Okay. You've got 10 teams and you need to select 2 of them. So just punch it in, 10C2. Well, you don't even have to punch it in. There's the answer right there. But do you see choice C, 10P2, right? You gotta sit there and go, ooh, does the order matter? Like, and you just gotta really, you just need to put your pencil down and turn your brain on and just think logically. Like, don't try to math it out. Just literally go, okay, well, A versus B is the same as B versus A. Okay. The other identical idea behind here is handshakes in a room. So it will say there are 10 people in a room. Each person shakes hands with every other person exactly 1 time. How many handshakes occurred? So if I reach over to Morgan to shake her hand, would that be the same as her approaching me to shake my hand? Yes. So Maxine and Morgan is the same as Morgan and Maxine. Okay? The order doesn't matter. So again, it's 10C2. Okay? So they're sneaky. Okay, a couple more and then we're done. Okay? Fred and Josephine, not necessarily in that order, are the first and second students in a line of 7 waiting to buy tickets for a concert. The number of different orders in which the remainder of the students can line up behind them. So here's my question. Do we even care about Fred and Josephine? No, they are part of the story, not part of the solution. Because the question just says, how many orders are possible for the remainder of the students? We don't care about Fred and Josephine. It's frustrating. When it's part of the story, it's like, ooh, that's sneaky. Okay. They are first and second in a line of 7 students. So how many students are behind them? 5. So essentially, it's how many ways can you arrange 5 students? How many choices for the first kid? Then, then, 5 factorial. Okay? Okay, so a pathways question. It's not a guaranteed diploma exam question, but they're fairly common. Okay? So how many ways are there from going from point A to point B without backtracking? So this is what we did by counting corners. Remember? So you start off with a 1, and you go left, or sorry, right, sorry, my other left. You go right and down putting 1s. And then what you do is you take your fingers and you count your corners coming in. So for this corner here, I go 1 plus 1 is 2. For this corner here, 2 plus 1 is 3. And I continue on. 1 plus 2, 3 plus 3, 1 plus 3, 4 plus 6. Once you get to this point, you now take that 10 and go left or right. Geez, what's my problem today? Right and down, writing in 10. And now we keep going like we did before. 10 plus 10, 20 plus 10, 30 plus 10, 40 plus 10, 20 plus 10, 30 plus 30, 40 plus 60. There are 150 ways to get from point A to point B. Now, there are 150 ways for you to screw that up. And it's an adding screw up, right? You'll write 2 plus 3 is 6, okay? Or you'll accidentally go 2 times 3 instead of 2 plus 3 just because you just will. You'll have a brain fart. You will know if you screwed it up, though, if your answer is not in the multiple choice list. You will not know if you screwed it up if it's a numeric response question. No. It is vetted through 3 separate levels of teachers and then field tested at least 3 times before it ever appears on an actual diploma. Each question takes about 4 years from development to appearance. So they're good questions. Like, I might not like the questions, but they're good questions. It's just some of them are hard, right? But yeah.